In this chapter, we are going to learn about spectroscopy and flame test principle. I'm going to discuss about definition of spectroscopy and flame test. Spectroscopy is an analytical technique used to study in interaction between light and matter. It helps identify and analyze chemical substance by observing how atoms or molecules absorb or emit light at specific wavelength. Definition of flame test is a quantitative analytical method used to identify metal ion. When a sample is heated in a flame, metal ion produce characteristic color due to electron excitation and emission. Next page is about basic principle. In basic principle, we have to learn about interaction between light and metal, electron excitation and emission, and why spectroscopy and flame tests are important in chemistry analysis. First thing first is interaction between light and metal. When light interacts with atom or molecules, it can be observed, emit, or scattered. Absorption of energy causes electrons to move higher energy level, a process called excitation. When electrons return to lower energy level, they release energy in the front of light, producing characteristic color. Second point is electron excitation and emission. The flame provides energy to excite electrons in metal ions. Each element emits a unique color when its electrons return to lower energy levels. The last point is why spectroscopy and flame tests are important in chemistry analysis. This technique helps identify unknown elements in compounds. They are useful in quantitative analysis and in understanding atomic and molecular.
Hi everyone, my name is Sharifanelia and I'm going to talk about spectroscopy principles. So first off, absorption spectroscopy. What is absorption spectroscopy? Alright, so the definition is that absorption spectroscopy is a study of how matters absorb light, which is an electromagnetic radiation, which is could be infrared radiation, gamma rays, as electrons, molecules or atoms move from a lower energy state to a higher energy state. The second is emission spectroscopy. So what is emission spectroscopy? So it is the study of light emitted by atoms or molecules when their electrons or other energy carriers drop from higher energy level to a lower energy level, which is basically the opposite of the absorption spectroscopy. So if we look at the pictures here, we could clearly see what is the difference between the two. But clearly, what we could see from the picture is the emission spectroscopy. It has a discrete lines, whereas absorption spectrum have an even line like a rainbow. So the next slide shows us that. So what is really the difference? The difference is that emission produced when atoms release energy, while absorption produced when atoms absorb energy. And then the second is comprised of colored lines in the spectrum, and then absorption comprises of dark lines over gaps in the spectrum, which is a discrete line. Next is atomic emission spectroscopy. So what is it exactly? So atomic emission spectroscopy is a technique used to identify elements by studying the light they emit when their atoms are excited. So it could be purple, yellow, green, and everything. What can it detect? Mainly sodium, potassium, calcium, and iron. Sodium, which is very useful for detecting trace amount of elements. Next is that AES is an important analytical method that uses light emitted by excited atoms to identify elements. It is widely used in science, medicine, industry, and astronomy.
Okay, so next we move on to the next topic, which is flame test principle. This topic consists of flame test theory, heating metal ion in flame, electron transition, flame color and explanation, and lastly table of flame test color. So first thing first, we need to know the theory of the flame test. So basically, a flame test is all about heating a metal salt in a flame. It excites its own electron, causing them to jump to a higher level. So this theory is presented by Robert Bunsen and Gustav Kirchhoff in 1860s. So you guys can watch these links that I have copied in the slide to imagine the whole overview about this flame test theory. Okay, so next we move on to the next subtopic, which is heating metal ion in flames. And there are some reasons why the metal ions produce a different type of color during flame test, which is the first one is energy absorption. It occurs when the electron absorb a higher thermal energy. And the second one is electron excitation, which is the electron jump from its own stable state. And the third one is the electron release energy, which is we call as emission, and it's fall back into its own stable state. And the fourth one is light So next we move on to a light emission, which is we know when the electron fall back and release the absorbed energy, which is we call as a photon. And lastly, the characteristic of color, which is depends on the wavelength and the specific electron energy level. So we often get asked what is electron transition actually. So electron transition is basically a valence electron or its outermost shell or any electron gain its own energy and jumping to a higher and from a higher unstable energy to a lower and more stable energy level, so that the electron release the exact energy difference that we know right now as photon energy. So next we move on to the flame color explanation. So why does the flame has a different types of color when they undergoes combustion, which is the reason is caused by these three factors, which is atomic structure, energy jump, and visible spectrum. So for the first point is atomic structure, which is we learn that the number of electron and their energy level can be a factor why the flame color is changing for each element. So as you guys can see, the flame color of metal ion that I have inserted in there, maybe there is because some reason, which is atomic structure or the number of electron and their energy level. So that's all for the part 3, which is flame test principle. So next we move on to the part 4.
To talk about problems, comparison, and solution. The common problems and challenge are similar reaction of metal ions. This is because some metal ions give similar colors, making them hard to distinguish, since ions have similar chemical properties. The second are presence of interfering ions, that is called by force result and mixed observation, that lead more than one metal ion may react with the same reagent and interfere with each other test. Next are limitation of flame test. The first are sodium interference. Even with a small amount of sodium contamination, it can produce a strong yellow color flame that will mask the color of other metal ions. The second are low sensitivity. The flame test cannot be done with a very small concentration of metal ions. And how does spectroscopy solve it? In spectroscopy, the light will be emitted by excited metal ion is separated from individual wavelength and will produce a unique line spectrum for each element. Spectroscopy also solves for sodium contamination by isolating the sodium wavelength which allow other metal ion to be detected with more clearly. And this is the flame test and spectroscopy comparison. The flame tests are based on color, low accuracy, low sensitivity, and have similar color that may lead to confusion, while spectroscopy based on wavelength, high accuracy, very high sensitivity, and has unique spectrum for each metal. And real-world application of spectroscopy of environment. Spectroscopy plays crucial role to protect environment by allowing scientists to detect
and measure pollution, and it is also used in monitoring air, water, and even soil quality that will help to protect our.
This slide shows the limitation of both methods. Flame tests only give qualitative results. It cannot show the exact concentration of metal ions. Some metal ions have similar flame colors. The flame colors can also be affected by impurities. Instrumental methods are more accurate, but they are expensive and complex. Next, challenges. There are several challenges when using these methods. One of the main challenges is the high cost of equipment. Flame test is simple, but it is not very accurate. Instrumental method requires skilled users. The equipment also needs regular maintenance. And then, in the future, analytical instrument may become cheaper. The accuracy of metal ion detection can be improved. Flame tests can be combined with modern techniques. This can help to get better and more reliable results. Laboratory testing methods will also become faster and safer. In conclusion, the flame test is a simple and fast method. It is suitable for preliminary identification of metal ions. However, instrumental methods provide more precise results. Both methods have their own advantage and limitation. The choice of method depends on the purpose of the analysis. There are the references used for this presentation, including textbooks, lecturer's notes, and reliable science website.